Welcome back to section 4.2. In the last section, we looked at graphing exponential functions, and so now we're going to look at solving exponential functions. And so take a look at this equation right here. 3 to the x plus 2 equals 3 to the 4x plus 5. So what makes this different than what we've solved so far? Remember that the reason this is going to be a little bit different than what we've done before is because this time the x is in the exponent. And over here, x is the unknown is in the exponent. So we're going to have to try to do something different than what we've done before. Now I'm going to show you a little shortcut right here. And I'm going to skip a step, and I'm going to explain it in a future video, okay? So this will be easier to understand if I just show you the how to do this skipping a step, and then we'll explain it more in detail later. So here's what I'm going to say. Excuse me. Here, do you see how we have 3 to the x plus 2 equals 3 to the 4x plus 5, and these bases, the 3's, are the same? If this equals this, and the bases are the same, then it's logical that the exponents have to be the same. So if you have 3 and 3, then it's okay to write x plus 2 must equal 4x plus 5. Hopefully that makes sense. 3 to this stuff has to equal 3 to this stuff, and since the bases are both 3's, then the exponents logically have to be equal. And so now we can just solve this. So minus x, 2 is equal to 3x plus 5, minus 5 minus 5. 2 minus 5 is negative 3. So we have negative 3 equals 3x, divide by 3, divide by 3, x equals negative 1. So if the bases are the same, then you can go ahead and just set their exponents equal to each other and then just solve. So let's go ahead and plug this in and see if it works, because you should always do that. If I plug in negative 1 right here, I get negative 1 plus 2, which is 1. So on the left side, I get 3 to the 1. Let's plug in negative 1 here. I get 4 times negative 1 is negative 4. Negative 4 plus 5 is 1. So I have 3 to the 1 over here. And these are obviously equal. 3 equals 3. So that's the answer. So why don't you try to solve this one on the right on your own. Pause the video here, see if you can get it, and then we'll see if you get the right answer. So go ahead and pause for a second, see if you can get it. All right, hopefully you gave it a shot. Again, the bases are equal, the exponentials are equal, so therefore we can set the exponents equal. We can write x is equal to 3 times x minus 10, because we had 4 and 4. Obviously, if there was something else being added here, if there was pretty much anything else in this equation, we couldn't do this trick. And so that's why I wanted to show you this first, because this doesn't always work. So let's go ahead and now just solve this. Do the distributive property. X equals 3x minus 30, because 3 times x is 3x. 3 times negative 10 is negative 30. Now let's subtract the 3x on both sides. X minus 3x is negative 2x. Okay, got all our x's on one side and numbers on the other. Divide by negative 2, divide by negative 2. X is equal to negative over negative is positive. 30 cut in half is 15. So there's your answer. X is equal to 15. So let's plug that in. Wow, we're going to get 4 to the 15. I'm not going to do that in my calculator because it's going to be huge. Is that equal to, if I plug in a 15 right here? So is that equal to 4 to the 3 times 15 minus 10? What do you think? Is this going to work? 15 minus 10 is 5. 5 times 3 is 15. So on both sides, we get 4 to the 15th, so it works. So as I said, this trick will work if the bases are the same and there's nothing being like added on the end. Like if I wrote plus 2 here, this suddenly becomes a much more difficult problem. And we'll learn how to solve that later. All right, so let's look at these two. Do you notice that these do not have the same base? So we're going to have to be clever here because we have 3 and 9, so we can't use the trick I just did. So I'm going to do something really clever here. I'm going to break down this 9 into a 3. Let me show you how. Do you agree with me that 9 is equal to 3 squared? Hopefully you do, because 3 squared is equal to 9. So I'm going to take the bigger number and break it down to the smaller one, and here's how. The left side, I don't change anything. On the right side, instead of 9, I'm going to write it as 3 squared, and here's what that does. That's how it breaks down. So this 3 squared right here is still equal to 9. And notice I had to put the 2 here, and I had to put the rest of the exponent in parentheses. And then we're going to do distributive property just like we did in the last example. So really see how I did that. The left side I left alone. I attacked the bigger number, broke it down into a 3, and made it 3 to the second power, and the rest of the exponent went into parentheses. Again, if I took 3 squared, I could make it 9 again. Now, the reason I did that is I have 3 and 3. So now I can solve x plus 2 equals 2 times 5x minus 7. And hopefully now this is an equation that you can just go on autopilot. Do the distributive property. X plus 2 equals 10x minus 14. Let's bring all our x's to one side and add all of our numbers to the other side. So I'm kind of doing 2 steps in one here. X's cancel, I get 16. 10 minus 1 is 9x. 10x minus x, I mean, is 9x. And the 14's cancel. Divide by 9, divide by 9. X equals 16 over 9. So that one little trick here in the beginning is a little tricky at first, but you'll get the hang of it. All right, you could also turn this into a decimal and then plug in the decimal to see that it works for both, and you will discover that it does. Now let's do the last example. Again, I need to somehow get 49 to turn into a 7. Actually, I need to get it to turn into the square root of 7. So how am I going to do that? Well, again, attack the bigger number is my strategy. You can also attack the smaller number, but it's a little more confusing, I think. I always go for the bigger number. So let's start. Again, leave the left side alone. I can rewrite 49 as 7 squared. Okay, so instead of 49, I'm going to write that as 7 to the 2x. Okay, again, this 7 squared is 49. And remember, if I had more stuff here, I have to put it into parentheses like we did right here. But since it's just x, I can go ahead and just write 2x. Okay, we're almost there. I still need to get it into the square root of 7. And luckily, we know that 7 is equal to the square root of 7 squared. Look at that for a second and make sure you agree with me. Do you agree that 7 is equal to the square root of 7 squared, because the square kind of cancels the square root? So we're going to do the same process again. So again, leave the left alone. Now instead of writing 7, I'm going to write the square root of 7 squared. And we still have 2x already up here. So take a minute and make sure that makes sense to you, because it's a little weird dealing with exponents like this. The square root of 7 squared is equal to 7, and the 2x is the 2x. Why did I do all of that? Because now the bases are the same, which means I can just set the exponents equal to each other. X plus 3 equals 2 times 2x. Again, only do this step if these two are exactly the same. I couldn't do that step when I had the square root of 7 and 7. I could only do it when I had the square root of 7 and the square root of 7. The next line is x plus 3 equals 4x. Minus x minus x. 3 equals 3x. Divide by 3. Divide by 3. X equals 1. So you now know how to solve equations where I have x in the exponents. If the bases are the same, you can just go straight to setting the exponents equal to each other. If the bases are not the same, then hopefully you can figure out a way to turn the bases the same by using squareds. You can even use cubes if you need to. Like if this had been 3 and 27, you could rewrite 27 as 3 to the 3. So that's kind of tricky. So now the question becomes, what happens if we can't do this? Like what happens if it's like 3 and 4, for example? And to do those, we're going to need to reintroduce that step that I've been skipping. And we'll look at that in a future video. I hope this makes sense. If you have any questions, please leave them in the comments. If you like this, like and subscribe, and I will see you in the next video where we continue looking at some applications of exponential functions.